This is Tim Koster and Martijn Plugge from Interdops. And what we want to present today is the Interdops mirroring integration, which is basically a way to load deltas from Datasphere to other systems without premium outbound integration. The reason that we did start building this was obviously because of the SAP note that you're probably aware of. So there is this SAP note that says that you can only use the ODP framework towards an SAP system. That's a quick summary of that note. That also means that you cannot use third-party tools to extract your data from an S/4HANA system, for example. But you always have to go through Datasphere, which is obviously quite okay for us. But if you're going to use premium outbound integration, that might become pricey. We were looking for a way. I was not going to say around it because it's not really a way around it. It's a definitely a different mechanism to get data from A to B. Where premium outbound integration uses Parquet files and is able to push data into your data lake. We found a bit different way to extract the data from Datasphere. This is the SAP node. So basically, and all credits to Martijn here, but the logic that we built looks like this. So we have an S/4HANA system. We have a replication flow towards that S/4HANA system that's inbound into Datasphere. And what we do in that replication flow is we add two fields to the original source table, which is called change type. That always consists with an U, so it always gets a U. And we have a change timestamp, as we call it, which is basically the current timestamp at the moment of loading. Based on that, we can actually determine if a record that we loaded, if we have already loaded that before, or that we, or that was deleted, for example, etc., etc. So what we're loading now is so we're loading through the replication flow into a local table. Then we take a data flow and we load the key fields that were, it's a bit complicated with all the timestamps that are in there. But so we take the timestamp, we take the last day basically, and we're loading that to a local table again, where only the key fields are sitting. And in that way, we are able to check if something that we loaded in the past is still there or not. If not, then it's probably deleted. The other thing that we're doing from that same local table is that we're determining if a certain record is new or an upsert. And together, we basically combine all those things in a SQL file, SQL view, and we are able to we're able to give that SQL view towards a third-party data platform. In this case, obviously, Microsoft through the open mirroring standard. Yeah. Anything you want to add there, Martijn?
No, I think that's the most important part. The thing on the right is the complete check to determine the deletions and to also delete to actually delete those deletions basically. So that if you load the second day, you will not check for those deletions again, but they will be deleted. Here and there, you see something like -1 or more than 3 days. That's obviously we can change that, but we are doing that so that that you will be able to load multiple days basically. So if you miss 1 day for any reason, the next day you can still load that data, but you can also choose to just basically load only 1 day or 2 days or whatever. And maybe one addition is the check if the load is initial. So for the open mirroring standard, we have to fill the row marker with a 0 the value 0. And this view checks if the load is initial, then it will give the row marker the value 0. Yeah, it's basically to make it work.
Yeah, so that's needed for the initialization on the Microsoft side, basically. So it's not something that we actually need in Datasphere, but it would not work from the mirroring side. It would not work without that view, right? Yeah,
exactly.
Yeah. So well, as you can see, we are not generating. We're using quite a lot of objects here. So that's yeah. It seems a bit complicated, and it is a bit complicated, to be honest. Yeah, what I want to show you is how it looks in Datasphere. So for anyone who has not seen Datasphere before, this is Datasphere. And what we're doing is basically this is the most important view inside that. We also have SQL on Datasphere side, so that's good. And what we're doing is we're determining what are the new and the modified records, and we're determining what are the deleted records. Yeah, and we load those through data flows. So data flows are basically like you would have a data factory pipeline. So they're loading data from A to B. So they're loading from one table to another, and we're using these views to load data from one stage to another stage. Just seeing that from one local table, so from one source table, basically, you need quite a lot of objects. So although the concept of this is quite good, or is actually awesome, if you would roll this out like over a complete S4HANA system, this would give, I think, the guy or girl who's going to build this quite a headache. So what we did actually on the other side is it's important to know that every object that is generated in Datasphere is actually built up of a season file. So if you go into the what we call the text space of a certain space, then we can actually look into the definitions of a certain object. So that one view that I just showed you, it's built up of a season file, and that season file is basically a JSON file that looks like this. So knowing that, we could manipulate this in some way. There's another feature in Datasphere which is called the command line interface, and through the command line interface we can actually push and pull objects to and from Datasphere without the need to go into the GUI. And that's something that we use now to are able to generate objects that we need in the open mirroring solution, basically. So you see all these objects here. At this moment, we are able to generate all the local tables and SQL views that are needed. We're looking into a way to also generate the replication flow and the data flow to make it complete. But for now, what we can show you is the generation of the other objects. So what we do is we go into that text space basically through some Python. We pull the season file from the local table that was generated, so this one. And based on that, we will generate all the other objects. So if we look into the those mirroring space, there currently is only the objects that consist of the replication flow and the local table that the replication flow is loading towards. And all the other objects we will show you will be generated on the fly, basically. So what we did is we have this this Python script, which consists of quite a lot of functions, obviously. And what we're doing is we're going to generate the objects. So we will start. And what you can see here is that this looks quite a lot like the season file that I showed you earlier. So it's taking the season file from the database from the local table, it's extracting everything that is in there, so all the files, etc., etc. Not all the files, all the formats, etc., etc. And it will start generating now the SQL files. It will start generating now the local tables, etc., etc. And as you can see, it's also deploying those, so it's pushing those towards Datasphere. It takes a little bit of time, but it will eventually generate every object that we need. So it already generated the local table where the delta is captured. It's now working on the deletions, as you can see. And for time purposes, we will obviously speed this up. So now it's finished. So it actually pushed all the objects towards Datasphere. And if I now do a refresh on this space, then you will see that all the objects that are generated now are there and also deployed. So that means that they are working and that the SQL checks went correctly. So we have 3 local tables, the ones that were in the presentation, and we have 3 SQL views that we use to determine any logic between those tables to actually generate the delta towards the open mirroring table or view that Ernst is going to show you in the demo that follows. Okay, thanks so much for your attention and see you later.
Till next time.